Hello friends, myself Jitendra Kumar. I am taking power electronics for the third year students. In the previous lectures, we will discuss about the DC choppers. We also discuss the various types of choppers and the switching mode power supplies, buck converters. But then we will discuss about the boost converters, boost switch mode power supply, their circuit diagram, waveforms, equations, their applications, and now we will discuss about the buck boost switching regulator. The buck boost switching regulator is a combination of buck and boost converter that produces an inverted negative output voltage which can be greater or less than the input voltage based on the duty cycle. The buck boost converter is a variation of the boost converter circuit in which the inverting converter only delivers the energy stored by the inductor L1 into the load. The basic buck boost switch mode power supply circuit is given like this. The same circuit we are opting for the buck converter, but in this case we have the capacitor usually arranged in this format that can give you the buck and boost both kind of operations. This will be the waveform. It will be the same as the buck converters and the boost converters. First one will be the load current, where the I-min and the I-max will be given. So then the load voltage, Vs for the minus V output. Then the output current, it will be continuing in nature. Then there is a capacitor voltage, the charging and the discharging and the linear and the parabolic operation will be there. For the discharging operation, the linearly discharge is there, and for the charging, it will be parabolic. Means the impact of the capacitor is more dominant as compared to the inductance, right? When the transistor switch TR1 is switched fully on or closed, the voltage across the inductor is equal to the supply voltage. So the inductor stores energy from the input supply. No current is delivered to the connected load at the output because diode D1 is reverse biased. When the transistor switch is fully off or open, the diode becomes forward biased and the energy previously stored in the inductor is transferred to the load. In other words, we can say when the switch is on, energy is delivered into the inductor via the DC supply, via the switch, and none to the output. And when the switch is off, the voltage across the inductor reverses as the inductor now becomes a source of energy. So the energy stored previously in the inductor is switched to the output through the diode, and none comes directly from the input DC source. So the voltage dropped across the load when the switching transistor is off is equal to the inductor voltage. The result is that the magnitude of the inverted output voltage can be greater or smaller or equal to the magnitude of the input voltage based on the duty cycle. For example, a positive to negative buck boost converter can convert plus 5 volt to plus 12 volts step up or plus 12 volts to plus 5 volt is step down. The buck boost switching regulator steady state output voltage V out is given as V out equal to V in into D upon 1 minus D. But whenever we are just compare about the operation of the buck converter, we are finding that the V output equal to V in into D. For the boost converter, V output equal to V in into 1 upon 1 minus D. So it's a buck and boost converter. So there is a combination of V output equal to V in into D upon 1 minus D, where D is the duty cycle of the choker. Then the buck boost regulator gets its name for producing an output voltage that can be higher, like a boost power stage, or lower, like a buck power stage, in magnitude than the input voltage. However, the output voltage is opposite in polarity from the input voltage. Now, this is the end of the buck boost converter. Thank you.